Okay, so
we can start, sir.
Yeah, we can start the session. Hello, everyone. Very good evening to all of you, and very warm welcome to all of you to our IITMAA Guru Talk session. My name is Papia. I'm a team member of IIT Madras Alumni Association. On behalf of my team, I'm very happy to introduce Professor Manasa Ranjan Behera. He is one of our prominent alumni. Professor Behera earned his MS degree in 2006 and PhD degree in 2010 from Ocean Engineering Department of IIT Madras. He did his postdocs at the Tropical Marine Science Institute, Singapore, and also at the Institute for Energy System, University of Edinburgh, UK. After that, he joined IIT Bombay as a faculty member in 2013. Today's Professor Behera's topic of discussion is coastal vulnerability in a changing climate. Topic sounds very interesting to me. Hope all you have the same feeling. And I'm requesting all the attendees that please, you all are welcome for question answer session. So type your questions in the chat box. Professor Behera will try to answer those. Please welcome Professor Behera. Now it's over to you, Professor.
Thank you for your kind words, Papia. Now I will share my screen and then I will also get started. Please let me know if my screen is visible.
It's visible.
Okay, and I'm audible clearly, right?
Yes.
Okay, so thank you so much. Now, before I start, it is my pleasure to be part of this IITMAA Guru Talks. And as alumni of IIT Madras, I take pride being called IITMAA or alumni of IIT Madras. So I am currently working at IIT Bombay, but I have very good collaboration as well as close interactions with IIT Madras and all my colleagues as well as my teachers over IIT Madras. And today what I am going to talk about is coastal vulnerability in a changing climate. And to this talk, I invite all the attendees, audience, and welcome them wholeheartedly. And if there are any questions, any discussions, please put it in the Q&A chat forum, and we will discuss them towards the end. So let me quickly start with today's discussion or today's topic. The reason why I chose this topic for discussion is mainly because everyone is talking about climate change, and we are also being affected by the vulnerability of climate change. But how extensively are we affected by this coastal vulnerability? How our coastal community and coastal stretches are affected by this climate change? So that is what is something that I want to discuss. So to give an overview of what are the aspects that or the stresses that we will be looking at when we discuss the coastal vulnerability. So first one is wave impact. So we know that the waves are the perennial entities in the ocean. They keep on hitting the coasts and they will have some impact. So if there are any changes in the wave characteristics due to the climate change, there will be some impact along the coast. It may affect in terms of erosion, in terms of accretion, or in terms of any other coastal stability change. And in addition, we will also have sea level rise impact. So we have been talking about global sea level rise scenarios, local sea level rise scenarios. We'll be talking about all those in details as we move on. But there will be some impact of the sea level rise in terms of coastal inundation, flooding, or so on. Then we have cyclones. These cyclones are there, and we have observed that the cyclones are frequent visitors to the east coast of India, as well as recently they have been frequently visiting west coast of India, and we have been receiving them and we are affected by them substantially. So every year, once before monsoon, once after monsoon, there is a high possibility that we are hit with the cyclones. So how we should be prepared for that? What are the measures? What are the developments that are required in terms of cyclone vulnerability? Then storm surge, which is again associated with the cyclones. So when cyclone comes, the surge or the mass of water that comes in and hits the coastal infrastructure, coastal region, coastal buildings, and so on, and how that affects the coastal community. That is something we should be also concerned about. Then tsunami, which is not so frequent, which happened last in 2004, but they also do affect. But in terms of climate change, so far there has not been any clear indices telling that there is impact of climate change on tsunami. So, but this is again type of coastal disaster, coastal vulnerability that is also going to affect the coast. But we will not talk much about that in this lecture or in this talk. So what are the things that it's going to affect? All these factors, what we said, they're going to affect mostly the coastal community. And in terms of coastal infrastructure, coastal settlements, coastal community, these are going to be affecting. So now, in addition to that, there is one major factor which is also affected is coastal water quality. So coastal water quality is gradually being affected by all these changes that are happening. I have only listed few of the stresses, few of the areas where it is going to affect, but there are actually many. The list is quite long. I will not be able to cover everything here, but at least we can understand there are too many things. So in terms of the biodiversity, in terms of the coastal processes, everything is going to be affected if there is any change in the coastal process or coastal parameters. So let us first discuss about the climate change impact on the ocean waves. So when we talk about climate change impact on the ocean waves, we did a study considering the whole Indian Ocean region. Obviously, the reason why I'm specifying this whole domain is anyone who is trying to study this impact of waves, it is necessary that one has to consider the whole domain, that is extending up to -40. Sometimes it is also recommended to go up to -60 south. So one has to consider the whole domain because the activities in the southern Indian Ocean do affect the wave activities or wave parameters or wave characteristics in the Arabian Sea and Bay of Bengal that we call it as northern Indian Ocean. So after considering that, we can only study the wave characteristics in the northern Indian Ocean, that is along the west coast of India, along east coast of India. So we did carry out the numerical analysis and numerical study and observed that the wave characteristics in future are going to increase. So we observed that in near term, that is something we consider as 2011 2040, and another time span as mid-term, that is 2041 to 2070. And we observed that the wave heights are increasing, and when we compared both 2040 to 2070, there is an increase in the wave heights. So there is increase in the near term as well as there is further increase in the mid term. So I'm not displaying all the results here, but at least we understand that there is an increase. So in addition to the wave increase in the significant wave height, there is increase in the maximum wave heights. So maximum wave height is the peak wave height that is observed in a series of waves. And when we talk about significant wave height, that is something in technical term, we call it average of highest 1/3 wave heights that are recorded in a duration. So waves are random, so we cannot really take each and every wave height and do the analysis. So we have some standard terminology to consider, that is significant wave height and maximum wave heights that we analyze. And we have observed that both are increasing in future. And more importantly, the mean wave period. So we know that waves are hitting at every span of few seconds. So there is a period of the wave, and if this wave period is going to change, then the impact or the effect of these waves along the coast is also going to change. Various structures, various facilities that are designed for specific wave heights and specific wave periods. Now, if in future these wave heights and wave periods are going to change, then the design parameter has changed. So how well our infrastructure is equipped for this kind of changes, that also needs to be evaluated. So to do that, we need to first understand what is the change going to be. So that is one part. Then second, if you see here in this compass plots, this shows the wave directions. And as you can see, the near term and mid term, there is a significant shift in the wave direction. So if the wave direction changes, there are many factors which are going to be affected. Sometimes we design our ports, harbors, or various facilities based on the wave direction. And if the wave direction is going to change, then the operational days or the operational characteristic of these facilities are also going to be affected. So we need to be concerned about that. So that is also something we have studied and we have evaluated. So we have evaluated for many locations, but here I have just shown it for 9 locations. And once we have done this kind of a country scale study, we also wanted to understand what happens in the localized scale. So we have done it. Okay, so there is a publication here listed at the bottom. In case somebody wants to understand more and find more details about it, can go to this publication and read it. So we tried to understand in a deeper scale or in a finer resolution. So we took the coast of Maharashtra and we pointed out various locations at closer spacings, and we understood how these waves are going to be changing over the future. So we first analyzed the historical part of that, and we understood that the wave heights have a trend. So we could see that the annual mean significant wave height is gradually decreasing at some locations. At some locations, it is increasing. So to understand further, we actually dissected this into different spans. If you see, we have taken here different spans, that is from 1979 to 2019, and suddenly there was a drop at some point. That also we considered. Then again, there is increase. So we try to understand what is happening. And then we also analyzed the pre-monsoon and post-monsoon scenarios of this changing wave heights along these locations. So finally, we could see that, yes, historically there has been some trend, and in future also there is going to be increase, and this same trend is going to continue at some locations, and there are some locations where the trend is actually deviating. So it might have been decreasing in some at some location in the past, but in future it is possibly increasing. So those are the details that we have analyzed, and we have reported in the historical part of that we have reported in this paper. And then we carried out the impact of this increased wave heights on the coastal stability. So anytime the wave height is going to change, it's going to affect the sediment transport or the movement of the sand along the coast. So we call the sand movement along the coast as longshore sediment transport, or it is denoted as LST here. So as we can see here, we have evaluated the wave characteristics along all these locations that are marked here in these dots. And at the same dots, we have also evaluated the longshore sediment transport for the near-term scenario and for the mid-term scenario. And we can see clearly that there is a difference, or there is a change in the longshore sediment transport from the near-term to mid-term scenarios. And if we evaluate the net change in the longshore sediment transport, that is shown here, at different locations the change is different. So it indicates that not each location is going to have similar kind of change. Depending on the wave height, wave direction, it is going to vary. So now, earlier the Central Water Commission has carried out a study and prepared one coastal stability plot or map, coastal stability map, that is shown here, that is from CWC, which shows there are some stretches which are stable and some stretches where accretion is going to take place or deposition of sand is going to take place. There are some stretches where erosion is going to take place. So we also followed the similar process and similar pattern to prepare the coastal stability or coastal classification maps for the near-term and mid-term scenarios. And these are based on the large scale or broad scale study for the whole Indian continent. But if the same kind of study what we are carrying out for the localized or every state with higher resolution points or locations, then these results are also going to be improved, and we will be able to prepare, which is under the process, and we are in the process of doing it. This work is again available in this climatic change journal, and you can always refer that. After doing this exercise, we wanted to understand how these changing wave heights are going to affect the coastal infrastructure, especially the port facilities. So what we did, we considered number of locations along the west coast. So if you look at L1, L2, L3, L4, L5 are mostly the coastal states that represent, but along each coastal state, there are a number of locations we have considered. As you can see here, number of port locations are denoted here. So for all these locations, we carried out study, numerical modeling study to identify if there is there is a change in the wave height, then what will be the impact on the forces on this, on the structures that are present along these locations. So we considered three different cases or three different scenarios. The first scenario is the present case or present condition of the coast, that is present water depth, and at present whatever is the wave height, that is what is considered as case 1. And in case 2, we considered the depth which is going to be same, but the wave height which is going to change, and whatever the change of wave height is going to happen by 2100, that wave height we have considered and we have implemented to understand what will be the forces on the structures. Then the third case or third scenario is we consider the sea level rise. So we evaluated the sea level rise at various locations and used that sea level rise as increase in the water depth. And then with increase in water depth and increase in wave height, we analyzed what will be the forces on the structures. So after carrying out this study, we observed, this is a typical plot of what I am showing here for, let us say, the location at Kambat. We can see here for the case 1, it is the force is very low, and for case 2 and case 3, the forces are significantly increasing. And similarly, this is for vertical force, this is for horizontal force, because there could be horizontal impact or vertical impact, so both the forces can be separated out. So we have analyzed vertical and horizontal forces, and the same analysis has been done for all the locations. And as you can see in this table that we have shown, the case 1, case 2 and case 3 are presented, and for case 2 and case 3, whatever is the percentage change that we have observed at each of these locations, that are also listed here. There are few locations where we have observed forces have reduced. It is not necessary that everywhere the force is going to increase. It all depends on the wave heights and the sea level rise scenarios at those locations. There are locations where there are 600% or 800% increase in the forces. So we need to understand this and then design our structures. This is done for 2100. Let us say somebody wants to design the structure for next 30 years, but at least somebody has to consider the scenario for 2050 and then analyze and then take the forces into account and design the structures. Then only it is going to be safe and it will be serving the purpose. So that is the motivation behind this work. However, this has been done for the West Coast. Similar studies under the process for East Coast. One can always take that up and study it. Okay, this is available in this journal, ISS Journal of Hydraulic Engineering. Further, after talking about the waves, now let us discuss about the cyclones. So cyclones, as I said, they have been hitting the coast, East Coast and West Coast almost every year, but East Coast has been more affected compared to West Coast. And there was one event in 2018 where we have seen two cyclones simultaneously on both the ocean basins, that is Bay of Bengal and Arabian Sea, which you can see on the right hand side. So, but eventually many studies have focused on the East Coast, and less studies or less focus has been given to West Coast. But considering the recent trend, it is also necessary that more focus is required for the West Coast cyclones and impact on the West Coast. I'll talk about it maybe in few slides. As we can see that statistics, numbers, everything shows that Bay of Bengal is receiving higher number of cyclones compared to the whole total globe. The number of or the percentage of cyclones are very less in the Bay of Bengal and Arabian Sea. But if we look at the people or vulnerability, then we can see that almost 80% of the global fatalities are caused by these 6% of the cyclones that are coming in the Indian Ocean, or that is in the Bay of Bengal and Arabian Sea. And We carried out a study in 2015, sometime before, and we have observed the power dissipative index of these cyclones have been increasing over the decades. Last 1 or 2 decades, we have seen that the power dissipative index is substantially increasing, and that clearly indicates that uh, there is a need for uh, getting prepared for stronger or intense cyclones that are coming and hitting us in the coming years to see. So these are typical pictures or images that shows the devastation that has happened due to various cyclones. And as we can see, the devastation at different locations could be different, but the economic loss could be different for, again, different locations. Let us say there is a cyclone going to hit for Mumbai. The economic loss could be substantially very high. So uh, the casualty that could be again different at different location. It depends on the preparedness. So I will not spend much time on that, but I will tell what was the need for improvement, where we actually were lacking, and what was the requirement. Most of the times the cyclones or the storm surges, they are predicted using numerical models, and how well these numerical models were devised to cater to this kind of intense cyclones that are coming nowadays. So if you see in this picture, the left side animation shows the typical storm that is coming and the surge that is also propagating. So it is not only surge that it's going to be, there is going to be a surge, as well as there is going to be some kind of storm or you can call it waves or storm tide, that is in addition to storm surge. So everything is going to be together. Now, what is the mechanism? Where do we do the simulation, or where do we do the modeling? It is at the interface. So there is a strong wind which is blowing on the water surface, and the energy that is in the wind is transferred to the water surface, and that is going to drag your water, or that is going to drag the ocean's water, and that becomes your surge or the waves that are going to come and hit. So that right side figure which is shown here is the basic process. I'll not again take you to the integrity or theory of that, but to make you understand what we are trying to resolve. There are many processes. There are turbulence, there are sea spray, there is wave roughness, there could be many parameters which needs to be resolved. So all these things are resolved using a model called wave boundary layer model. And most of the times this wave boundary layer model is not used because these are computationally expensive. It takes quite a lot of time. So it is true that we need to get the results in a short span of time to get the warning to the public, but at the same time it is also necessary to represent the accuracy. So what we did, we considered this wave boundary layer model and did the analysis using numerical models. So most of the times you see people use different models. What we have used are the two models, ARTSERC and SWAN. Those who may be interested to know this more can possibly contact, no problem. So this slide is basically showing you the equations of ARTSERC, SWAN and wave boundary layer model. So I will not bore you with the equations, but to give you a feel of the complexity of the equations and of the study, I'm showing this slide. So what we are doing in this, we are trying to incorporate the drag coefficient that is happening within the interface. That is using the wave boundary layer model, we derive the drag coefficient, and that drag coefficient is fed into these models to incorporate the energy transfer from the atmosphere or the wind to water. And then we have carried out number of modeling studies, and based on our modeling study, wave boundary layer model study, we have got number of data points, and based on that we have devised a wind drag formulation, and which we call it improved wind drag method, IWD method, and that we have given here. So the difference between this IWD method and other methods which were earlier is basically the IWD method can represent very high wind speed up to the order of 70 or 90 meter per second. So that is typically your super cyclonic storms. You can call it hurricane category 5, or in Indian context it is super cyclones. So the wind speed are mostly of the order of 70 meter per second or more. So this IWD method can capture the drag coefficient for wind speed up to 90 meter per second. So that is what we have derived, and one can very well avoid using WBLM method, which is very time consuming method, but this IWD method is almost 2.5 times lesser than the extensive computational method. So whatever the current computational time, with the same time we can get the better output. So better output means the surge, storm surge that we are predicting is going to be much better. The wave heights that are going to be predicted due to the cyclones or the storms, that are going to be better. So this is what was the requirement, and we have developed this. It has been incorporated in this model at CERC, and anyone who wants to study or who wants to use this model can always contact us and can make use of this. Further, we have also investigated various impact of the angle of attack. Now, depending on this changing climate, the cyclones are also coming and recurving themselves at different locations. So the cyclones can impact the coast at different angles. So we have considered a typical scenario where the cyclone comes at different angles and hits a concave coast. So we have observed that if such kind of scenario occurs, if the cyclone hits at an angle of 75 degrees, the angle is measured from north side. So if it is going to hit at 75 degrees, then the surge is going to be maximum, or the impact is going to be maximum. So these kind of studies are required for various typical scenarios, difficult coasts, and we should create such kind of scenario and keep it ready as a database, so that at the time or at the need, we should be able to provide this information to the public as and when required. Although we have carried out various other process or the physics that are involved, so those things are available in this journal and one can always go through that, but overall idea was to create such kind of database or to create such kind of knowledge so that it will be useful for the public. Then we have also evaluated the effect of cyclone intensification period as well as the cyclone distance from the landfall, because with the changing climate pattern, the cyclones are not as usual in the earlier. So sometimes they intensify very quickly, and the intensification period is also very short, but the intensification location also does matter. So where do they intensify? If they intensify in the deep ocean, if they intensify very close to the coast, if they intensify in the shallow regions, what is going to happen? So we considered number of cyclones all the way from 1982 to 2020. And we analyzed all the cyclones, their landfall, their intensification periods, their distance and the location, everything. And we calculated the scenarios. So we considered different scenarios, as you can see here. Some cyclones, they intensify and continue the intensification for longer period, that is around 24 hours. Some cyclones intensify for, let us say, 6 hours, and some cyclones intensify for at different locations in the deep ocean region, in the shallow region. So all that we have analyzed, and based on that we evaluated how the cyclone impact is going to be at the coastal locations. We considered a specific location, that is the KG basin, and the reason why we considered, because number of installations in terms of offshore facilities are coming up in this KG basin region. So we wanted to analyze what is the impact of that in this region, but similar studies can be carried out for various locations. So this, again, this study is available in the journal Climate Dynamics for reference. Having done this, there is also a need. We have carried out a study of coastal inundation for different storm surge impacts in changing climate. So there are studies which have already clearly mentioned that for RCP, which is now mostly referred as or the new scenario which is considered as SSP, shared socioeconomic pathways. So this is representative concentration pathways, that is 4.5, which is basically a moderate scenario, and RCP 8.5 is a kind of extreme scenario. So for moderate scenario, it was suggested that there will be 7% increase in the wind speeds of the cyclones, and for extreme scenarios, there will be 11% increase in the cyclonic scenarios. So by considering that, we also carried out simulations or flooding scenarios for different locations. I'm showing one of the location that is a extremely severe cyclonic storm, which is having a landfall at Puri. And if that landfalls at Puri, then at the location Paradip, which is slightly away from that, what will be the flooding? So it is seen that in the current scenario, it will be flooding to some extent, but if we go for 4.5, the flooding is increased. And if we go for 8.5, the flooding has substantially increased. Not only at this location, it has increased also various other locations away from this. So it is necessary to prepare such kind of scenarios and keep this kind of maps or the scenario maps ready, so that at the time of the event, we don't have to again really go for the simulations. We can straight away give the warnings to the public. And this is also required for carrying out various other infrastructure planning and development. So one of that we carried out for the government of Odisha is identification of location of cyclone shelters, and we also designed the cyclone shelters which are suitable as for the NDMA guidelines. So this is a study which is a huge study we carried out considering various road network, population, water body network, and all other guidelines of the NDMA based on the cyclone shelter locations and other characteristics. And we carried out the storm surge analysis, tsunami analysis, everything. So we classified the zones. As you can see, there is no shelter zone. So at the red patch is basically identifying that there should not be any cyclone shelters located in this zone, because that is not going to serve the purpose. So we have to place these cyclone shelters away from this zone. So starting from zone 1, the cyclone shelters will be located. So earlier, when the cyclone shelters were constructed, they were constructed randomly at any location, but now there are guidelines. Based on the guidelines, we have devised this, and we have given a list of priority where the cyclone shelters have to be constructed first based on the need and so on, and where they can be constructed later. So we have also given the design. I will not get into the design part of that. We have given the complete design of the cyclone shelters for various capacity of the shelters. Further, this kind of events can also affect various coastal infrastructures which are possibly very sensitive, and you don't want any kind of inundation to take place for such kind of installations. So in that case, we have different mechanisms or different mode of protections, and most of the times in such kind of scenarios, hard measure is bound to be adopted. But in case the hard measure is adopted, whether it is going to be sufficient or not, that is again another question. So usually if you have the hard measure, then still there might be overtopping depending on the surge characteristics. During cyclones, there could be huge storm surge and storm waves. So we also proposed the crown walls. And when we proposed crown walls, the crown walls can have different profiles. Number of profiles have been studied by various authors. As you can see here, number of profiles were studied by these authors, Anand and Sundar, and we carried out the study using all these profiles. And we observed that all of these profiles are not really stopping the flow completely. There is still overtopping. And for the structure where we want zero overtopping, we had to really go for another modified profile. We carried out number of scenarios and number of profiles we have tested. Finally, we came up with one modified profile, which is named as FB, that is front and back 2 radius profile with some kind of characteristics as you can see here. And with that, when we tested, we observed that there is completely zero overtopping. So the mechanism which actually happened there, the wave comes and quickly within short span of time that is overturned and thrown back into the ocean. So depending on the characteristics of the wave heights, surge heights, this design has to be planned, and then it has to be implemented so that we can achieve the required purpose or required zero overtopping scenario at locations. So this is what another study which I would like to also emphasize, that this kind of study has to be done case to case basis, not applicable for each location. You cannot take this design and implement it anywhere where different types of surge or wave height scenario is going to be affecting. Having said there is hard measure, there are other locations where we also want to have soft measures. So usually that is first priority. We always intend to recommend soft measures for such kind of coastal protections. So this is a study which we carried out for soft measures. You can see the kind of debris or the debris materials which are carried during surge that comes and hits the coastal vegetation, and if it hits the coastal structures, how the force is going to be on the structures. And we also carried out if there are vegetation and the surge or flow that passes through such vegetation and carries this kind of debris, and then they hit the coastal structures, how the impact of this debris will be on the structures. We carried out using numerical models and we carried out using experiments. So both the studies were reported in the journal that you can see here in Applied Ocean Research. If you want, you can refer that further. Next, I would quickly highlight some of the studies that we carried out on extreme wave impact analysis on coastal deck structures. So why I'm focusing on deck structures, many of our coastal facilities have deck structures that are present. So if the, excuse me, if the wave comes and hits the deck, so there are two types of forces which are going to be there. One is vertical force, one is horizontal force, which I kind of indicated earlier. So if there is a vertical force, then what will happen? The vertical force is going to lift the deck, and then if there is a horizontal force, a small amount of horizontal force can completely distort or displace the deck from the support. Initially, what we do, we assume that the deck is placed at sufficient clearance so that the wave is not going to hit. But those structures which have already been designed, they're existing, and now the climate change scenario says that the wave is going to increase, wave height is going to increase, there is going to be a rise in the water level due to sea level rise. So there is a possibility that the waves during storm conditions can come and hit the decks. So if that happens, then these are the kind of disasters which may occur. And if such kind of scenarios occur, then we should also identify or find out the forces that are going to act on the structures. Then only we can design or we can plan for such kind of remedies. So to find out the forces, we carried out numerical investigation using a model called REAP 3D. And using that model, we carried out number of simulations, and based on that, we figured out the coefficients, horizontal force coefficients, as well as vertical force coefficients, which are derived using the value S and H. What is S? S is the clearance or the air gap. So why air gap? Because the air gap which is currently available might reduce due to the sea level rise or due to any elevation, or during a surge, the sea level could substantially reduce first and then the wave comes and hits. So to account for that, one has to take care of that in S. Then H. H is the wave height, where the increased wave height can be accounted for. So once you account for S and H, then you can calculate the force coefficients CH and CV to calculate your horizontal and vertical forces. So once you calculate your horizontal and vertical forces, next designing is the rest part that can be done. So similarly, this is done for solitary wave. Similarly, we have also carried out and derived the expression for non-breaking focused waves. We have carried out and identified the expressions for breaking focused waves. So breaking in the sense, if the wave comes and breaks on the structure, then what will happen? The force, we know that the breaking wave forces are going to be almost 8 to 15 times higher than the normal waves. So that needs to be evaluated separately. So that's what we have carried out and devised the formulations. Now, further, I will quickly highlight one aspect that is required to be kept in mind, that most of the studies when people do for climate change analysis, we use the forcing as wind. Whenever we do the analysis or we carry out the simulation of waves, we use the wind input as our forcing. So this wind is obtained from various climate models. There are a number of climate models. We call them GCMs, global circulation models, and we have RCMs. So whether it is GCM or RCM, we need to evaluate them and we need to find out which one we should be using. In general notion, people say that RCM is better. Why? because it has finer resolution or closer spacing of grids, so that it is expected to be better. So we wanted to evaluate that. So one of the PhD student carried out this work and analyzed using something called total relative score. So we call it TRS. And this is something new method that we have devised, TRS, using various statistics that are available for evaluation of such kind of uh, model outputs. So what we have done the analysis for wind alone. This may not be applicable for other parameters from the same models. This is applicable only for wind. So what we did, we calculated the weights for each of these statistics. If you see the Delhi mean, the Parkin skill score is the one that is most suitable for finding out the Delhi mean statistics. And based on that, we calculated some weight. And similarly, there is annual cycle, annual mean, seasonal mean. So for everything, there are different statistics. So we, instead of considering each statistic separately, we have to find out a cumulative approach so that we can pinpoint a suitable model, and that can be used for our analysis. So we devised this TRS method, and using that, what we did, we evaluated all the climate models. We considered almost 35 climate models from GCMs, CMIP 5 GCMs, and all of them, when we evaluated, we found that there are models which I'm not listing the name of the models. They are available in this paper. You can go through this paper, which is published in Atmosphere, and that model number, which is specified as 27, next is 10, and next is 13, are performing better than other models. Now that is about GCMs. So similarly, we also carried out the study for RCM. So this is again a chart which shows this 27, 10 and 13, and taking the ensemble of these three, we have also generated another model output, which is 30. I will be talking about that later. So similarly, we also carried out the study for RCMs. For RCMs also, we found similarly the best performing models. Now, one has to check whether RCM is better or GCM is better. So then we carried out a combined analysis. Our combined analysis shows that the model combination of these ensembles of GCM is 30, and combination of top five RCMs are 33. So these 30 and 33 are the ensembles of GCM and RCM. So when we checked that, we found that GCM is performing better compared to RCM. And when we looked at individual models, we found that GCMs are performing better than RCMs. And in some cases, there are some parent GCM and parent RCM. So it is not necessary if the parent GCM is good, parent RCM is also going to be good. This is because there are different processes which are changed based on the models. So those processes are going to drive the model is going to perform well for specific parameter representation or not. So that is why we have carried out this analysis, and we have clearly mentioned that this model 30 is the output from GCM can be used for wind input for various wave modeling. So this is important because many students are now going to use wind input for wave modeling for future scenario forecastings. So you need to consider this aspect before you actually use a generic ensemble of all the models. So it is very necessary that you take care of this. Now we are also looking at ensemble of the combined Southern Indian Ocean and Northern Indian Ocean, and that is something we are carrying out now, which is again the scope for further studies for many. In addition to that, when I would like to highlight one aspect on the sea level rise part. So when we are talking about sea level rise, we talk about this relative sea level rise. So what is relative sea level rise? There could be rise in the water level. There could be also lowering of the land, or we call it land subsidence. So we carried out a study that is to evaluate the land subsidence, and we did the study for Mumbai region. We found out various land subsidence at various locations, and then similar study is going to be merged with the sea level rise study, which is currently again going on. And this is a map which is shown for flood prone areas with different sea level rise scenarios. What we are going to merge with, we are going to merge with some studies for sea level rise that we are carrying out now. So this is the coastal states. I'm focusing on the Tamil Nadu coast. Along Tamil Nadu coast, we have carried out a numerical modeling study. In this study, we have incorporated the sea level rise values in the model. So you can see here different sea level rise values at different locations. It is not same. It is varying. So local sea level rise is going to be different for different location that we have to consider. And once we consider that, then we can identify, let us say the current scenario, I'm showing the intertidal zone for the year 2015. So if we take 2015 intertidal zone, this is the area, various black patches are shown here. And similarly, if I see the intertidal zone in 2100, then this is the area. So as you can see, I'm just moving forward and backward to show you the change or the difference. So there is area which is marked here, area in square kilometer, which is going to be covered in this intertidal zone. So as you can see, in 2100 it is 2.559 square kilometer, whereas in 2015 it was 2.835 square kilometer. It might have reduced, but the major concern is the inundation which is extended landward. So now that might affect various locations where settlement might be there, number of houses might be flooded, number of locations which might be affected. So these are the study which are carrying out, which is still ongoing. And again, further detailed study is required. Many students can always take up investigations in these directions. And this study and the previous land subsidence study, something that I have shown, we are going to merge them together to find out exact analysis of the flooding that is going to happen at various locations at some sensitive areas. So before I end or close my discussion, I would like to thank my research team or research group who have done the work. It is not me who has done the work, they have done the work. So I am only speaking on behalf of them. Thank you so much. And now, Papia, over to you. You can moderate and we will be able to take some questions.
Hello, sir. A few questions are there in the chat box. So you can just, can you hear me?
So, yeah. Should I see the chat box and then respond, or what?
Yeah, it will be better because, some terms will be difficult for me to tell you correctly.
Okay, so I'm just going through the chat box. So one question says shoreline at LOC 1 and 9 receives the maximum impact of wave energy, yet the shoreline is stable. Can you please explain this anomaly? The maximum energy, it could be due to first of all, let me explain how do we define the stability. It is the net sediment transport. If the net is 0, then net longshore sediment transport is almost negligible, then we call it stable. If the net sediment transport, longshore sediment transport is in negative, that means there is erosion. If it is positive, that means it is deposition. So if maximum wave impact is coming to that location, but it has more impact in the cross shore direction, that means it is directly or hitting normal to the coast, then possibly the cross shore sediment transport could be significant. In future, cross shore sediment transport could create the erosion, but not the longshore sediment transport. So these maps, what I have shown, are based on the longshore sediment transport alone. So that is something I want to again clarify. Is it a 2-dimensional model or 3-dimensional model? How do you determine the effect of bottom friction? First of all, this is not the sediment transport is calculated using a bulk formulation, that is Kaczmarek formulation. It is not a physics-based model. So we have not used any bottom friction in this. We have used the sediment grain size, but in the currently we are working on the numerical model, which we are also going to compare the results what I have shown and the results what we will be arriving at. So we'll get in comparison, but what results I have shown are based on the bulk formulation. That is Kazmarek et al. Formulation in 2005. The next question is from okay, thank you for the insightful talk regarding our coastal vulnerability in view of the climate change. Would you please let us know your thoughts about our current preparedness and coastal resilience to such vulnerabilities? Okay, current preparedness and coastal resilience is, again, there are a number of institutions and organizations who are working on this. Obviously, we are providing our research outputs, but institutions like INCOIS is working on this prediction of or forecasting of cyclone storm surge. IMD is predicting the cyclones. INCOIS is predicting the storm surge, and NIOT, they both are working on preparing various maps and charts. Then we have NCCR, who is the institution is also working on various coastal maps and coastal vulnerability maps and so on. So there are preparedness and a lot of models and the tools have been designed. But having said that, still there are lot more improvements, lot more infrastructural capabilities are also required, which again in the pipeline by the government. So more than that, I don't think I'll be able to discuss within this short span of time. So then that is also another follow-up question. In your experience working with government authorities or LDMA in this aspect, that would be appreciated. Oh, okay. So yes, we did work. We only considered the NDMA guidelines, but we worked with OSDMA, Odisha State Disaster Management Authorities, to prepare those maps. How did you validate your numerical model? Field measurements or with physical model study? We mostly validated with the field measurements, the data or the field data that were obtained from INCOIS. INCOIS has the data bank. So we mostly obtained our wave heights, wave period, wave directions, all the wave data, or even the tide data, whatever required from INCOIS. And we validated our numerical model results with those data. What made you question the dominance or accuracy of RCM method over GCMs? It is not questioning, it is what we have evaluated, and we have shown that that it is not for every parameter. As I said, we have carried out the analysis for wind speed, and for wind speed, the processes or the physics that is being used by different models could be varying, and the way they represent, when we calculate and we evaluate the statistics, we found that GCM is performing better. So it is not necessary that RCM is bad for every parameter or RCM is bad at all. So depending on the use, one has to evaluate and take it forward. How confident are we that the present climate model can predict the cyclonic phenomena in future? See, the problem is the climate models, the resolution is too coarse right now, and we are possibly with the computational efficiency, we are moving further, you can say, finer resolution. So there might be a time when we can also represent the cyclonic phenomena. Currently, they are not captured so well. To some extent, if you look at the output from ECMWF, from various cyclonic, from various numerical models that are there, they reproduce, but not exactly. So we need a lot more work. And the first of all, the resolution of the models have to improve. Then the physics or the processes for the cyclonic phenomena has not been incorporated so well. So that possibly is not the immediate focus of the climate modelers. And that is something which is, again, needs to be done in future. But I'm sure people are working on that. They will be doing it. How are the improvement and modification to the models are done? This question possibly I could not understand. Is it related to the previous question? I'll assume that it is related to the previous question by the same person, because it is, yeah, it is from Vinu. Okay, so Vinu, this is the improvements or modifications to the models are done by the climate modelers, which possibly I am not very confident to tell how this is done, but it's obviously with the process representation. And as I said, let us say we are talking about the cyclones or the storm surge. So obviously they both are two different models. You take the wind input from the atmospheric model and give it as a forcing to the ocean model. But if we take coupled models, ESNs, so then in that case, this interfacial processes or the wave boundary layer model, which I discussed, has to be implemented or incorporated so that we can get a clear transfer of energy from atmosphere to ocean. Next question is from Dr. Jaikumar. Manas, did you validate the land subsidence results from satellite with any field data? Yes, we did carry out, we collected the satellite data, sentinel data, and we compared our results with the groundwater level information. Although it is not necessarily a direct correlation, but it gives kind of indices. So it correlates to some extent whether the groundwater, we collected the data from the Central Groundwater Board, and with that we validated our results, and that is under publication or under review for publication. So yes, we did it. Then next comment says good work done. Thank you so much. Kindly elaborate on the effects of marine structures due to ocean acidification lowering the pH value of ocean water due to climate change. This is something which I would love to, but I have not really gone much into this part. So I don't think I'm competent enough to talk about the ocean acidification right now. So I will possibly leave this question aside. And then the last one from Dr. Samuel Devdas. It is an informative talk. You and your team has done tremendous work. Okay, thank you, Dr. Samuel. Thank you so much. Yeah, so that's all the questions I could see in the chat box. If there are any other questions directly, I can also answer them. Papia?
Yeah, just let me see the gallery view if anybody is.
There is a question there, just now it came. Did you use IBM mainframe or PC with GPU? It is high-end workstations that we have used, not mainframe. And we have a space-time computational facility in the institute. We sometimes use that also. Yeah. Yes, Papia, over to you.
Yeah, I think you have answered all the questions. Thank you so much. It is really a wonderful session. I'm sure all the attendees have benefited from your lecture, and your ideas and content are very thought-provoking on the subject. So let us close this session now, and we truly appreciate your time and interest to make this event successful. And thanks to all the participants.
Thank you so much, Papia, and thanks to IITMAA for organizing this, and thanks to all the participants, and thanks for the intriguing questions that were really exciting.
Thank you, Professor Bera. This is Nishani. It was a wonderful presentation. And I'm sure everyone loved it because I can see so many people stayed on for so long and asked many questions. Thank you so much. IITMAA looks forward to engaging with you in future in many more programs. Thank you so much for your time. Thank you, everybody.